One of the challenges of creating a program is the techniques on how to search specific data on a list. Last time I already discussed to you what is a linear search and how does it work. But today I'll be searching to you, showing to you, or discussing to you another technique on searching, which is what we call binary search. Let's consider the following data. The following data has a length of 5 and the left is equal to 0, left is the first left side, and the right is equal to 5, which is the length of the array, and target is equal to 100. Let's consider this one as 0. This variable will be our reference on the later part. Okay, now, so how does a binary search work? So suppose that we have a block of an array. We have a block of array. What it does is it divides the actual array into a half. Okay, this half. And for each of this half, the following conditions are being checked. So is it the actual value of the half or the mid? The data on the mid, right? The data on the mid is equal to the target. Okay? Equal to the target. Okay? So if it is equal to the target, then return the value of the index or the position of the array. However, if it is not equal, what happens is we need to check the value of the mid, the value of the mid, if it is, or the target, if the target, okay, if the target is greater than, okay, greater than the value of the mid, okay, greater than on the value of the mid, therefore you need to update the value of left. Okay, the left is 0. So what happened is that since we already updated the value of mid, or check the value of the mid, we need to add +1 to the mid. So basically, mid +1. Okay, no need to compare the value of mid. However, if the target, okay, target is less than, okay, than the mid, less than the value of the mid, therefore you need to update the value of r, and mid would be -1. Mid -1. So that is the first step. Next iteration, you validate it again, this one, until such time you already found the actual data. Okay, let's see how does it works in this following list. So on our data, we already have this following information: length, left, right, target, and mid. So in order for us to identify the mid, you need to add the value of left, the value of right, divided by 2. So the value of left is 0 plus 5, right, divided by 2. Therefore, it is 2.5. However, you will be considering 2 for that one. Okay, 2. So the mid would be this part. Okay, now let's check our condition. Is it mid equal to the target? So the mid is not equal to target. Okay, so what happened is it will not return the value or the position, but rather it compares this data, this condition. Is it target greater than mid? Okay, so the target is 100 and the mid is already 33. Okay, the value of mid is 33. Therefore, it says that you need to update the value of L, right? The value of L, mid +1. So therefore, the value of mid is 2 plus 1 is equal to 33. Okay? So it will be equal to 33. Okay? So no, it would be equal to 3 rather. Okay? So it will be equal to 3. So it will be updated. The value of the left side, the index or the reference of the left would be going here. Okay? So left and right. Now the following code again, we'll be validating it again. We'll be having a condition again. So where is the mid? Okay, where is the mid of 3 and 5? Okay, so you add 0. No? So we'll be adding 3 plus 5 over 2. And that is equal to 4. Okay, so we'll be updating it to 4. So 4. And then what happened is, since we are here 4, and this is our mid, okay? Mid. We need to validate the condition. Is it mid equal to target? So the target is 100, and mid is equal to target. So therefore, we end our loop, and we return the position 4 plus 1. We will tell the user that it's already existing in the actual array. Okay, so that ends the condition, or searching rather. So now let's do and apply this following condition into codes. Okay. Binary search is very interesting, especially because the way compared to the processing of the searching compared to the linear search it is a lot more faster. Right now we assume that one, but later on we'll be discussing what we call big O notation to identify the processing time and to identify the complexity of the codes in terms of binary search and linear search. Okay, by default, we'll be using this one. Java, we need to declare public static void main. Now, we'll be doing our list. Declaring the left and right of the array or the index of the arrays so that we apply the actual condition that we already have done on our discussion. So the array length must be -1. Okay, let me tell you again that this one needed to be -1 because we start with the index of an array from 0. Now this is our control statement. On the while statement, it will not end the actual condition or the loop while the left is not less than or equal to the right. So the mid is represented by our bound or our boundary, and then left plus right divided by 2. That is our formula in order for us to identify the center or the mid of the array. So we apply the condition array or the target. Okay, so let's declare to search. What is the data that we search? For example, 98. Okay, so here we put the condition is to search. So to search search is equal to the value of the array bound or the mid. So if it is equal, so we'll be using the technique in Java, which is the break. Even though the while statement is not yet condition, the while statement is still true. What happens is if we use break, it stops the iteration. So here, another is we put else if. This is a ladderized condition or ladderized else if, ladderized if, wherein after checking if it is equal, we'll be using the else if to check whether the search is less than the array bound. Okay, here, see, right, we update the value of left in. Okay, right, we update it first, and then else if we have the search is greater than array bound. So if it is greater than, we add +1. Then here we declare a in position and found in order for us to identify the current position, and found for our checker whether we put the printing or not. Okay, actually you can put it directly here. You can put the actual code, but for me I'll just put it here. So system, if condition if found is equal to 1, meaning it is existing, therefore we print record found. Okay, so the main advantage of this one is that since we already have this one put in here, we can put else on the later part, the lower part, to verify if the data is not found. Okay, else if it is value is equal to 0, therefore record not found. Okay, so let's check if there's something that we have missed. The terminal, let's compile it. Okay, some errors. Check for that. Okay, comma. Don't be afraid to have some errors, because that's the way you'll be learning how to code. It's not always 100% if you're correct at the first time. Okay. Okay, there you go. It shows the position of 4, which is correct. Okay, so let's check it again. We have a value of 15. Okay, record not found. Okay, so value of 100. Okay, so that's how the binary search works, and hoping you learn for this specific topic. Thank you and happy coding!